Hi, I'm Radek. I'm a developer advocate at QuickNode, and in this video I will walk you through what is Etherscan, what people usually use it for, and what you can do with it to release its true power. I will show you 9 use cases from simple and helpful to really technical and powerful. Ready? Let's go! So what is Etherscan? Etherscan is a blockchain explorer and essentially a whole analytics platform for the Ethereum network. It allows you to search through transactions, blocks, wallet addresses, smart contracts, and other on-chain data. And what can you use it for? You can use it to help you understand how you interact with the blockchain, what's happening, how other wallets interact with the blockchain, how the apps, dApps work and interact with blockchain and wallets. It helps you to stay safe and spot suspicious behavior. You can check the smart contract that you're interacting with and see if it's legit or not. You can also check gas fees, search for airdrops, or even directly interact with smart contracts to make transactions. The most common use cases, though, are very limited. For example, people usually check if the transaction went through, and that's the only thing that matters to them. So if I have some transaction that I have just performed, what I want to see if it's a success or not, if the transfer went through, if everything was fine. And as soon as I see the green check mark, I'm done. And that's the extent that most people interact with Etherscan. Some might also use it for quickly checking the gas prices. The smaller the gas price, the lower the fee that needs to be paid for a transfer or an interaction with a smart contract. So people come and check the number. If it's low, they go ahead and transact. If not, they're waiting for a better time when the gas fee is lower. And that's how people usually interact with Etherscan. But it has much more to offer. And to be honest, Etherscan does not really reveal how powerful it is looking at homepage. It provides you with a search field where you can enter a wallet address, smart contract address, transaction hash, or token name. But other than that, there is not much more going on. You can check Ether price, both the current and historical. You can check the gas fees from homepage. It's growing. Not a good time to do anything right now. And everything else is not really that important for your day-to-day use. So it doesn't give you much more on homepage, but I will show you 9 use cases of what you can really do with Etherscan so that it shows you its power. The first and most important use case is to track transactions and wallet addresses and smart contract addresses. So for example, let's start with a transaction. If we know the transaction hash, we can enter it here and see what is happening with it. Now let's go through all the elements and see in detail what they mean. Transaction hash is the transaction that we have just entered. Status tells you about the state of the transaction. Success means that it went through. Pending means that it's still processing. And it can also be failed, means that your transaction has failed, which happens especially if you, for example, run out of gas. Block is the specific block that your transaction was included in. And you can also see the number of block confirmations since that block, which means that that many blocks have been added to blockchain after your transaction. It might be helpful in a way that the more blocks are added to blockchain, the harder it is to tamper with the transaction. Timestamp shows when your transaction was added to the blockchain. Addresses from and to, this is the sender and recipient of the transaction. So these are wallet addresses. This is a simple transfer between one wallet and the other. Value 0.1 Ether shows how much Ether was transferred in the transaction. Transaction fee is how much the sender paid the miner to perform this transaction, to perform this transfer. In this case, it costs 42 cents to send 0.1 Ether. Gas price is cost per unit of gas required for the transaction. It was 16 Gwei. Let's click and see more. Let's get all the details of the transaction. So in case of transfer, it's easy because transfer always costs 21,000 gas, no more and no less, and you don't need to set a limit. But if it's an interaction with a smart contract and you want to be prioritized so that your transaction go through before the others, then you can set a higher gas limit and it will show both the limit and how much it was actually used. If a transaction is running and it runs out of gas at some point, then the transaction will fail, but you will still have to pay a transaction fee because the miner has already performed the work. If you say a high limit for gas and not all of it is used in the transaction in interaction with the smart contract, then the remainder is returned to your wallet. Input data doesn't have anything for a transfer because it's just a simple transfer from one wallet to the other. This is more commonly used for interaction with smart contracts, like, for example, sending the parameters to the specific function. Now let's move on to some more interesting stuff. For example, the state tab, which is very rarely used. If you don't want to go into all the details of the transaction on the previous screen, you can go straight to State tab and see what is happening. The state is like before and after. What was the state before the transaction and what's the state after the transaction? And very easily you can see at a glance who did what, got what, or paid how much. For example, this address had 0 ETH before and 0.1 ETH after. So it was empty and someone sent 0.1 ETH to the wallet. And that someone was this exact wallet, which had 5.629 ETH in it. And after the transaction, it had 5.528. The state difference is not exactly 0.1 because of the gas fees that were paid to perform the transaction. But a transfer is one of the simplest transactions you can perform on Ethereum. So let's have a look at something more complicated. Like, for example, this transaction. So let's have a look at what's happening here. The transaction is successful. It happened 2 days ago and it transferred one Bored Ape Yacht Club from this address to this address. And from is the sender, and this sender interacted with this specific contract, which is Bored Ape token, and one ERC721 token was transferred from this address to this one. Value was 0 because it was a simple transfer. It was not a payment for it. This is the transaction fee. And if we click to see more, it shows additional input data, which is the function transfer address from, address to, and token ID. So it takes 3 parameters, from, to, and token ID, and these are the 3 parameters here. Now this is a more complicated transaction than a simple transfer, so it has more information as well. We can even go and see the token, the NFT here, and there's a wealth of information. So who's the owner now, item activity, so this 2 days ago, so this is the transfer, this is the transactions that we are reviewing. Since then it was transferred again. It was sold almost a year ago for 78 ETH almost, and we can see the history of all the movement and pricing here. So immediately from one transaction hash you can get a wealth of data. You can go to different marketplaces to maybe bid on this token. You can go and see the whole NFT collection that this transaction is for, and you can start the whole journey knowing what you know from one simple transaction. But it doesn't end there because it was an interaction with the smart contract. The smart contract has emitted logs. So when something happens in a smart contract, like a transfer, a sale, or anything other important, smart contracts usually emit an event so that then it can be logged and analyzed later on. And here we see an additional tab that wasn't present in a simple transfer with logs. We see 2 events emitted here, and these are the names of the events. One is the approval, the other is a transfer. Approval means that the person that sends the token needs to approve the one that receives it, that it can move the token from their wallet to the recipient. This shows that the owner with this address approves this token 6718 to be moved to another wallet. And the second event that is happening at the same time in the same transaction is the actual transfer. The transfer is happening from this wallet, from the owner, 749, which was the owner here as well, 749, to this wallet, which is the recipient, and this specific token ID. So while this screen is helpful enough with what it already tells, it has a few hidden gems in addition to what we have just seen. So first of all, if you want to really know what is happening behind those events, you can jump straight to source code of the smart contract for this specific token and see what is being emitted, where in code, and you can analyze the rest of the smart contract to really know what's going on if you want to analyze the details. And you can do the same for the second event, which is a transfer. And you can see that this is part of the ERC721 interface. And this is the event that needs to be implemented to be considered an ERC721, which is an NFT. And I talked about it in an ERC721 video, which probably should be somewhere here. And one more interesting thing on this page is this topics 0 that we haven't talked about yet. So these topics below 1, 2, 3, and more, these are the parameters of this event. But topic 0 is actually a hash of the signature of the event, which means that when you take this event, this specific bit, approval, index, topic, address, owner, and so on, and hash it with Keccak 256, this is the hash that you get. And why is it helpful? Because every time this specific event is fired, which is the approval event, or for example, a transfer event, it will have the same identical hash. And it's included in the logs. So we can search the logs for this specific hash. And when we do that, we will get all the events, all the approval events, for example, or all the transfer events. So this way we will be able to analyze and find specific things for the smart contract that we care about, which is, for example, transfers of a specific token or NFT. And the state tab for this specific transaction is quite simple. The owner had this amount of ETH, and now they have this amount of ETH, and the only difference is the fee paid for the transfer of the NFT. It wasn't a sale, it was a simple transfer of NFT. And this is a difference for the miner who mined the transaction. That's it. And to see an even more complex transaction, let's have a look at this one. This one is an interaction with a Uniswap v2 contract, and it's actually swapping Ether for OE token. What's OE? Let's have a look. That's old Ethereum. So let's see the details. So this is the wallet that was swapping. It was interacting with this contract, which is the Uniswap v3 router 2. It was transferring 0.5 Ether, which was first converted into wrapped Ether and then into old Ethereum token. To check more details, let's see what was the function call. The function was multicall, and we can see the logs that were emitted. There was a deposit log, there was a transfer log, there was another transfer log. These are all internal Uniswap logs. Then there was a sync log, and the actual swap. And again, to make things easier, it's good to see the state, what was before, what was after. So this is the address performing the swap. It paid 0.5 and some for the transaction. This is the address for wrapped Ether token, and then the state changes in old Ethereum token. So this is how you track transactions and addresses and smart contract activity. But this is only one of the things that you can do on Etherscan. And let's have a look at all the other use cases. The second use case is monitoring addresses. So Etherscan allows you to find information about a particular Ethereum address, such as executed transactions or owned assets. But it also has a watchlist feature, which allows you to set up an alert for specific addresses. In other words, you will be notified every time an address makes or receives a transaction. You can use it either for your own wallets to just keep track of what's going on and have everything in one place, to receive an email every time something is happening, or you can set up alerts for some like special addresses, maybe some smart contracts, maybe some whales which are trading and you want to copy trade or do anything else based on that information. And it's important to get that information as soon as possible. To access this feature, you need to create a free account on Etherscan. And once you are logged in, you go to drop down watch list. Here you can set up alerts. You can set up to 50. Every time anything happens, like a send transaction or receive token, you will get an email notification. Pretty straightforward. You enter the Ethereum address. You can optionally give a description of what it is. You can track just ERC20 tokens or also NFTs, ERC721 or ERC1155. And this is how it looks. I have one notification set up, and you can see at a glance the address balance. I have set up to get notifications on incoming and outgoing transactions and to track everything, ERC20 tokens and all kinds of NFTs. From here, you can easily go to this address and check the balance, check the NFTs, check everything about the wallet address. Watchlist and email notifications for transactions is a nice little known Etherscan tool, and there are paid services doing just this. You get this for free with Etherscan. You just need to create a free account. Use case number 3 is reading and analyzing smart contracts. To be able to read a smart contract, it needs to be verified, and it's easy to see if it is verified by a green check mark. If you see this green check mark next to contract, it means that it's verified and you can read all the code of the smart contract. And that's exactly what you see here. This is, for example, a smart contract for a USD coin. It's useful both for verifying what the smart contract does, but also for learning from high quality projects and smart contracts. You can check any verified contract on source code. For example, this is a smart contract for Moonbird's NFT project, and it's easy to see the smart contract source code. If you want to learn smart contract programming, for example, in NFTs or DeFi or in other sub-industry, you just go to the most popular high quality projects, read their source codes for smart contracts, and that's one of the best learning resources you can get. Use case number 4, staying with smart contracts. So in addition to reading smart contracts, you can also interact with smart contracts. You can read from blockchain and write to blockchain straight from Etherscan. To do that, again, you go to a smart contract source code, and there are 3 tabs at the top. The one that we have already seen is code, where you verify the smart contract code. And there are 2 more, read contract and write contract. This specific smart contract is for the Moonbirds NFT collection. And as you can see, there's a lot we can do here. So let's start with reading the smart contract. This is all the information that you can get from blockchain, from variables, from constants in the smart contract code. And let's check a few of them. Default admin role is 0, so probably the default admin is false. And this is the list of all the functions that you can use and read from. For example, balance up, you provide an address of an owner of this NFT, and it tells how many tokens they have. And a few easier ones is the name is Moonbirds. Is nesting open? It is. Who is the owner of the NFT of the smart contract? This is the address. The symbol of the token is Moonbird. Token URI. Let's see what's token URI for token ID 1. And we are reading straight from blockchain. And this is what we get. And this is token URI for token ID number 1. It means that the metadata for this specific token is stored under this address. And when we go to this address, this is the metadata, the name, number 1, the image, the trades, eyes, rainbow, outerwear, and so on. So all the metadata for this token. And if we copy and paste this image this is the image of this specific token. So all the information that we can get from Etherscan about this specific NFT. So that's reading, but we can also write to blockchain through Etherscan. We go to write contract and to connect to Web3 so that it's connected to our MetaMask, to our real wallet. This is now connected. And now we can interact with the contract. For this specific smart contract, this is an NFT collection. It's long since minted. All the tokens are already minted. So there is no reason for me to interact with the contract right now, unless I want to approve a transfer, for example. But it can be used, for example, for a new collection to mint specific NFTs straight from Etherscan without going to the site of the collection. You can do this through Etherscan by entering a few parameters and submitting the transaction straight to blockchain. Let's see the example without actually submitting it. So let's say it's a minting period. There are still tokens left to mint, and I want to do it manually. So I'll choose mint public. And here I now need to enter all the information for the transaction to go through. So this is just like raw interface. You need to know what you are doing. You need to know what you need to enter into each and every field. Otherwise, you may end up wasting gas, or even worse, losing your ETH that you have set to that smart contract. But if you know what you're doing, if you have read the smart contract source code, then you know what you need to enter here. So mint public, this is payable amount. So this is the amount of Ether that you need to send for that specific NFT. This is the to address. This is most likely your own address that will get the NFT. This is the number of transactions that your wallet address has performed in total. And this is some kind of signature which you need to figure out from the smart contract source. But if you know the signature, you can mint this manually and submit the transaction. Let's see another one. For example, pause. You can pause the smart contract, of course, if you are allowed to do that. But if you are, you can just go straight here and just submit a transaction. If I am an admin, if I am allowed to do that, I can submit the transaction, go to confirm, and I would pause the smart contract straight from Etherscan. This feature is also great, not just for minting, not just for interacting with the smart contracts that are live on mainnet, but also when developing smart contracts, when you still don't have the UI, when you still don't have the front end, you have just the smart contract, you put it on testnet, and you can interact and submit transactions without having all the front end and see how it works, if it works, and what else do you need to do in order for this to work. Now on to use case number 5, checking gas prices. And it's not just simple gas price checking. It gives you much more useful information. So right now, the average is 17 gray, but this number by itself doesn't tell you much. Of course, as always, the lower the better, but it also would be nice to have an estimate of how much you would expect to pay for a particular transaction. And this is exactly what this tool provides you. So in addition to giving the number, it gives you the estimated cost of transaction actions, and it provides a list of most common actions that people do. So a sale on OpenSea, it's about $1.50. Uniswap swap, about $4. Some more complex transactions, about $7.3. And you can go through the list, super rare sale, or adding liquidity on Uniswap, or registering a domain on ENS, $5.50. And you can see what is your use case or is similar to what you can do, and then have a rough estimate of how much you would pay. It also gives you an idea of the trend of the gas prices for the last 7 days. Is it growing and you need to act now? or is it dropping, and you can wait to have a better price. Now on to use case number 6, performing an Ethereum name service lookup. ENS is those .eth addresses. And you can go either to Ethereum name lookup here, and enter an ENS name lookup, or you can even enter it straight into main search field by zeneca.eth. Here are the details for zeneca.eth, and this is the address that it resolves to, and you can see all the details about that specific wallet. Net worth 36,000, net worth about 29 ETH, and it probably has a bunch of NFTs. Yeah, it does. About more than 39,000 NFTs as well, which you also can search here. Use case number 7, more big picture stuff, which is monitoring Ethereum charts and statistics. Go to resources, charts and stats, and here you have, for example, daily price chart for Ethereum in USD, and you can see how it's dropping, growing, trending. This is the all-time chart. Last year, going down, last 6 months, pretty stable. You can check the activity on the blockchain, daily transaction chart. Here you actually don't see the up and down movement of the price, so it's pretty stable, which is a good sign of the activity and building on blockchain. Ether supply growth chart. This one is interesting in a way that since ETH moved to ETH.20, it almost stopped growing. So there is not much more Ethereum on the market. It's moving to proof of stake, and it's nicely visualized here. And there are other useful charts for you to take a look at. Now, use case number 8, smart contract search. Well, this is a relatively new one, and it's not talked about much, but it's an extremely useful one. You can actually search smart contract sources that are verified on Etherscan and check the projects, the NFTs, tokens, and see what you are looking for. For example, let's try and find a typical function for NFT project. It's safe mint. The total number of records found is 55,000. And now an interesting part is here that we can sort by either nearest to oldest or, for example, the transaction volume. So where the actual activity is happening. We don't want the smart contracts that have 0 transactions in the last 6 months. We want projects that are active, that are popular, that are proven, and we want to learn from them. In addition to sorting, you can filter by solidity version. So you can go and search for just the latest one. You can choose by license type, contract addresses. You have many filtering options, and even the list here shows you already the helpful information. So first of all, where the source code was found, the line specifically, and then what the smart contract was. So this is the contract name, this is the token name where it was found, and this is the number of transactions so that you know that it's not a dead project. And if you want to see more, you can click on that and go specifically straight to smart contract code. It's an invaluable source for people that are learning, but also, for example, for people that are searching for vulnerabilities or searching for hidden gems. If you know something, if you know a specific piece of code and you are looking for more smart contracts using that specific piece of code, that's an easy way to. And the last, probably the most technical use case is transaction decoder. So let's have a look at a sample transaction. We'll have a look at the transfer of the 8 NFT that was in use case number 1. And there was already a lot of useful information in logs, in state, in information here. But you can go to transaction decoder, and this is similar information, but all in one place, all presented in a very easy to digest and helpful way. And it's easy to see what's going on in this specific transaction. So going quickly through it. So this is the block number where the transaction was added. This is the transaction cost in ETH and in dollars. This is the current fee. But if it's an older transaction, you can click on that and check how much they pay in dollars based on the price of ETH for that specific day, how much gas they used, and the emitted events. So this again is something that we have already seen in the logs, but this is all on one screen, all about one transaction presented in a helpful way. This is the difference before and after. And interesting stuff is also happening here at the bottom. So the execution trace. So what specifically is happening with the transaction is being run. So specifically for this transaction, this function is being called transfer from with these parameters. From equals one address, to equals the other address, token ID. And if we click on this function, it takes us to that function in the smart contract source code. So this is the specific function that was performed when the transaction was run. And it's good for analyzing what is happening, especially if there is some kind of problem, or figuring out what happened if you inadvertently interacted with some kind of rogue smart contract and you want to know what happened with your funds, for example. The execution function is all that is happening inside that function. So is approved or owner, checking, performing a transfer, checking if the sender is the owner, proving the token, emitting the approval event, and everything else. So this is the most technical part, but also easiest to analyze a specific transaction if you know what you're looking for, or if you want to deeply understand what the transaction did, what kind of function was called by this transaction, and what specifically happened and why, and where the funds went, where the tokens were transferred, and what was the state before and after. And it's all given for you in this one screen. And there you have it, 9 use cases for Etherscan. And now you see that Etherscan is not just a simple tool that you only use to confirm if the transaction went through or check gas prices. It's a powerful set of tools that lets you not just peer behind the curtain and see what's going on, but also to analyze every last detail of everything you want fast and convenient. So now when you're armed with this knowledge, go and be dangerous. Learn, build, have fun, and see you soon.